we're going to be generalizing transformations. Hopefully coming up with some shortcuts here, maybe making some sense of transformations, because they do come in pretty handy sometimes, just at random points throughout a math class. So we have a general function, y equals f of x. So just some thoughts here. This f of x that I'm boxing in is y. All right. How do we know that? Well, it says right here, y is f of x. So that box there is the same thing as y. Okay. Inside of that function is the x value. How do we know that? Well, it's right there. So that's the x value. Okay, and we know a lot about x and y coordinates. In general, if we change the y value, or if we change anything that occurs to this box, it's going to change, it's going to alter what happens to the y values, meaning vertically. And likewise, if we change anything with the x value, which is the input value, which is inside the function, it's going to change anything that happens horizontally. Okay, let me maybe give you some examples here. So for instance, if we multiply the y value by a constant, a, it's going to change what happens vertically. If we add or subtract a number to the y value, again, this y value is here, it's untouched, and we're going to add or subtract a number, that's going to change, again, something that happens vertically to the y value. Likewise, inside of here, if I multiply x by a certain constant value, that's going to change what happens horizontally in some way or another. And again, if I add or subtract a number, let's say h, just some constant there, again, that's going to happen. That's going to change what happens to the function vertically or horizontally. So let me just show you a few specific examples. This is very general, okay? So as a quick example here, I have two functions. We're considering y equals x squared, which is the parent function for a quadratic, centered at the, whose vertex is at the origin here. Notice what happens here. This is our y value right here. So this is our y value. Notice I've added 3 to the end of it, and look at the change. What happened? This parent function moved vertically. It moved up 3 units. Okay. Here's another example. Y equals x squared. Again, this is our y value here. And notice what happened here. I didn't change the y value. I changed what's happening inside of that function. So I used x plus 3, the quantity, squared. What happened there? Didn't it move horizontally? But look at this, though. This is kind of weird. It's the things that occur to x are counterintuitive, meaning they go against what you would expect to happen. Up here, when you add 3 to the y value, it moves up. You would kind of expect that to happen. Notice what happens here. If I add 3 to the x value, what happened? It moved left. That's counterintuitive against what you would think it might do, but let's try and make a little bit of sense out of this real fast. Let's think about this point at the origin here. Okay, it has the coordinates 0, 0. So when I plug in 0 for x, I get 0 for y. Over here, this vertex has the coordinates -3, 0. And take a look up here. It's not actually looking at this +3. It's thinking about what x value would create a y value of 0 here. And can you see that if you plug in a -3, we get 0 squared. So plugging in that -3 gets us to the same vertex value as plugging in a 0 here would be. You can explore that a little more on a graphing calculator if you want, or let me know in class and I can elaborate a little bit more. All right, let's take a look at some others here. All right, once again, I have this parent function, y equals x squared. This is the y value. What did I do here? I took 2 times the y value. And over here, I took 1/2 times the y value. And again, just to kind of make some sense out of this, 2 didn't necessarily make the parabola bigger. It actually made it steeper. So that's the way to think about it in terms of its steepness. If you multiply the y value by 2, it's going to go up quicker. It's going to be more steep. And if you multiply the y value by a number between 0 and 1, it's the slope. It's not going to go up as quick. It's not going to be as steep. So it actually looks wider in that sense. Looking at changing just the x values here. So again, here, that's the x value, and I'm altering what happens inside of this box here, basically, which is changing the x value. So if I multiply x by 2, again, counterintuitive. What happens horizontally? When you multiply x by 2, it's a horizontal compression. It took this parabola, squeezed it, compressed it. Okay? So, and there's a little bit of a gray area between a horizontal compression and a vertical stretch. I mean, think about simplifying this. What does it simplify to be? 4x squared. You could actually consider this like a vertical stretch if you wanted to. Compare these two here. It's actually, with that 4 versus this 2, it actually is steeper. It goes up more quickly. But again, right now we're just kind of analyzing what happens to x and y. That is a horizontal compression. And again, right here, multiplying x by 1/2, we have what's happening here. It's called a horizontal stretch. We're taking this parabola and stretching it wider, and we have that. And lastly, once again, we have our y value right here. What did I do to that y value? I made it negative. I switched the sign of the y value. So just take a look at what happened here. If I take all these y values and switch their sign, they're going to go from positive to negative signs. Okay? This one's a little interesting to think about here. Let's think about just the x value right there. And what did we do? We made it negative. That's going to change what happens horizontally. So take a look here. These actually don't look any different, but something has happened. You just can't tell. So I'll color code this so we can kind of see what happens here. Maybe a lot of you are predicting already what happens. So what happens when you change the sign of the x value? Instead of reflecting across the x-axis, changing the sign of the x value is going to reflect it across the y-axis. So on this one, because of the symmetry along the y-axis, it doesn't look any different, but things have changed. And again, you can explore that more in a graphing calculator, or ask me in class and I'll elaborate more.